So hello everyone, I'm Ragavendiran Balasubramanian from MTech-AR/VR program of IIT Jodhpur, here to demo my MTP-II project. My MTP-II project is called ChemSim Reactor, which is an extension for Nvidia Omniverse. The title of the project is Chemicals Reaction Simulation Engine for Nvidia Omniverse with LLM. So the problem statement that this project addresses is imagine modeling chemical reactions for educational or research purposes. It's a very cumbersome job. You would have to, it's a very time consuming and tedious job. So basically what this project proposes to do is to utilize the existing knowledge bases in conjunction with LLMs to render or automatically generate the molecular structures and reaction simulations. So this basically contains a wrapper around an LLM, along with a chemical reaction render engine, which creates USD files of the reactants and products of a chemical reaction. So USD files are basically universal scene descriptor files, which is a format that was developed by Pixar. Once you have a USD file for a reactant or a product, you can use it across all your tools like Blender, Unity, Unreal Engine, whatever tool you are familiar with. So whatever tool you are using for content creation for VR, you can use this specific USD format. So that is the proposal under this project, and the solution implementation is as follows. And we right now have a backend system which is basically capable of accepting any prompt that you send for any reaction. That prompt is sent to the backend, and then from the backend you get the responses, and then those responses are converted to USD files. Once you have USD files of your reactants and products, those are converted to a scene prim. So that scene prim is inverted. That scene prim can be directly imported to your scene space. So the project is entirely done as an extension, so it integrates with Nvidia Omniverse seamlessly, and you can play around with it within your Omniverse console. So that is the advantage. And since it's in Omniverse, you can co-create with any of your other peers who are working on the same project, and you can develop, and then you can collaborate and seamlessly work with any number of people, and you don't have to model molecular chemical reactions. So that is the output of the project. So let me go ahead and explain the block diagram and flow diagram of the project. So basically the project has four major blocks: the LLM block, which takes care of retrieval of the data from the knowledge bases and construction of the specific format of the data. We have connected the knowledge bases to the backend, so the backend knows the relevant prompts and lookup content to feed into the LLM. And from the LLM, the responses are then retrieved by the Chem API. A copy of it is stored in the database so that we don't keep repeating the prompts. And if we repeat it, we just get the same results from the database and not from the LLM. And the Chem API basically gives back the JSON. And once you get the JSON, there is a component render engine which renders your reactants and products as USD files. These USD files are then sent to an animation engine where they are put into the scene and the transition effects are applied. So in short, the process could look something like you open your ChemSim Reactor extension within NVIDIA Omniverse platform. You enter the chemical reaction or prompt that you want, and once you enter, it goes to the backend, and from the backend you get a JSON file, and that JSON file is basically moved to your render space. And from your render space, you can from your render space, once you have the USD files are converted to a USD file again, which is your stage prim. And in your stage prim, you basically simulate everything that you need on your scene, and all of these together are combined and then put together on your scene space. So this is how the extension works. So let me show you some of the outcomes. So on the left is what our extension is. You can see this on your NVIDIA Omniverse platform. Once you just copy it, once you clone it from Git and then import it into your system. And on the right, you can see the chemical reaction simulation engine with our UI. Our extension basically has three simple UI prompts. One is one space is just to enter the prompt that you want. And once you enter the chemical reaction prompt, you get a JSON file. You select the JSON file which you want to convert to USD. You select it and then it gets converted. You get the converted file, which you can import directly onto your scene. Once you import, you get a reaction summary of what that reaction is, and then what like a small description and the chemical formula of that reaction. Also, in addition to that, the scene prim contains everything in a very descriptive format. So basically, once you open the scene prim on your stage, you can look up and then you can find out each and every element and how it's connected, how it like what type of bonds are there, and everything can be seen within your stage prim. So let me move on to the actual demo right now. And yeah, so this is basically the Nvidia Omniverse platform, and let me start from the very beginning. At the top right, you have something called developer, and once you click it, you have extensions, and within your extension, you can search for ChemSem Reactor, which is our project, and this is basically our extension which we have developed and integrated into Nvidia Omniverse. So let me turn that off so you don't see the extension is gone, and once I turn it on, the extension comes back. So the extension is auto-loaded, so that's why it loads at the very beginning as soon as I open Nvidia Omniverse. So let me close this up. So within here, you can enter any chemical reaction prompt. Let me say nitration of benzene. And I hit generate. So what happens now is that this prompt basically goes back to the Chem API and then the LLM, and then the LLM returns back a JSON file, and then the JSON file is saved. And once we have the results, then we can basically see nitration of benzene. The JSON is there. We hit and convert, and once we hit and convert, then once the conversion process takes some time, and then once it's converted, we should be able to see it down in the drop down here. So we do see nitration of benzene. The most recent file is here. So once we click on it and then we hit import, it is imported into our scene space, and we get a reaction summary. Let me throw the reaction summary somewhere around here. So let's just have it. The reaction summary contains just a short description of what the project is. Like what the reaction is, along with some basic description to it. So this can be done for any reaction, any chemical reaction that you can basically come up with a prompt for. And let me zoom into the scene space. And now we basically have the reactants, and then we have the products. If we click on each reactant, you can see each reactant individually, and then if you go into detail, you can basically see the elements. That is, N stands for nitrogen, O stands for oxygen, and H stands for hydrogen. So you can basically look at it at a molecular level on how the reactions are, like how the elements and the compounds are constructed. And the same goes for sulfuric acid as well. So the other side is sulfuric acid, where we can look at H2SO4. So there is 2 hydrogens, and then there is sulfur on the center with 4 oxygen atoms that are aligned perpendicularly to it. So the other side is benzene. We do see benzene over here, and that is the bond structure of benzene. Let me hit play. Once I hit play, it goes to the results, and in the products, you have nitrobenzene on one side, and then you have water on the other side. So you can also see, you can go into detail with respect to how the prims are constructed. So this is what you get out of this extension. You get a very detailed prim stage, which aligns with actual molecular structure of the compound. So thank you all, and this is a complete demo of the MTP-II project. I am attaching the GitHub links along with the reference materials to the project. Thank you.